Hi guys, welcome back. Today's video is about the ecliptic plane. Why is it called an ecliptic plane? And why there is no plane on a globe? Well, I don't have to explain that, do I? We know a globe doesn't have a flat plane. Unless you want to listen to a lot of bullshit about, oh well, it looks level out to there and level out to there. No, they're talking about a ball. There's no plane on a ball, so they try to leave out the word plane and just call it the ecliptic. But we know otherwise here at the Tomb of Illumination, the truth of the matter, the flat earth physics. So let's get into it. Now it's all associated with the Physica Piscis, right? And we know the phi ratio. This isn't to scale, but of the two hemispheres, you got the central northern hemisphere right in there. You have the bigger, larger southern hemisphere out here, separated by the tropical gap, the dielectric, otherwise known as the seen in a microscopic point of view, black hole. Right, so here we have the northern hemisphere and the southern hemisphere. So we know the southern hemisphere moves around the north as the north turns. They sort of turn like this, you know, as the south goes all the way around. And what happens over the season, the tropical season, is the southern hemisphere contracts up into the north, right up to there, and then moves back out again. These are infinite all the way around here, okay? The whole field just contracts into the center. Well, the ecliptic plane, this is eclipting. See, it's eclipting, isn't it? The eclipting plane. Well, it's in this eclipting plane is where the sun moves, because this is the moving magnetic field, contracting in, expanding out. Down and out has the sun all the way around the Antarctica region 24/7. Up and in brings this ecliptic plane up and in, brings the sun up and in, because the sun follows the magnetic field, because the sun is in this ecliptic plane. They just tell you there's a lot. They just draw you a line on their globe and say that's the ecliptic plane. So this is why they call it ecliptic, because it's ecliptic, and at the same time it's going around. So it's a plane, ecliptic plane, around the circumference of the northern hemisphere, right? So it moves in and it's moving around this plane. You could say that's the ecliptic plane in there. So you get right up here, you get the sun right up here in June solstice, right up to the centre north here. Right to the June solstice, then it comes down, and then at the 17th of October, bang, pops out. Just done a video on that, haven't we? And then the sun is full time out here all the way around. Sorry, I've gone the wrong way. So the southern hemisphere comes right up into the centre Arctic here. We should draw the centre Arctic, shall we? Centre Arctic. Arctic. So it moves right up there to the June solstice, and then contracts back again. So it's eclipting. See the two hemisphere star rotations. The northern hemisphere inverted and expanded for the southern hemisphere. So these stars in here are the same stars in here, except they're seen this way. Not this way, they're seen that way now, and expanded, diagonally opposing each other. Just take something and go and stand in the mirror and you see the diagonally opposed situation. Because, you know, your right becomes his right, or that mirror's right. Your right's the mirror's right. Becomes over there. Now you're left. Pretty basic. So that's it there. So there's the ecliptic plane. So the sun moves inside within this ecliptic. Okay? And it pops out here. And it pops out here. You know, it gets to the point where it's not the ecliptic plane anymore, is it? Does it? So, ecliptic plane moving the sun all the way into there and out there. But as it pops out, that's it. It's sort of outside the ecliptic plane. See, in the night sky, this ecliptic plane, when the south moves away, it just leaves a small gap like this. That's the celestial gap. It's very small like this. But our realm has exploded, isn't it? So we get a whole 47 degrees between there and there. There's the northern hemisphere between there and there, right? That's the northern sky there. And then you've got the southern sky out here, moving all the way in, contracting into the center, and then expanding back out again. It just pops out a little bit here, and this is where you see Orion's belt come through, quite obviously. It's another story, because that gap there is hidden under the veil. It's a secret spot, okay? Even though we see Orion's belt passing through for 9 months of the year, it's hiding the overlay, because you don't see the overlay. You don't see the stars overlaying in here. You might see some more passing through here, maybe straight lines passing through here, but you know, the obvious thing is these stars in here overlapping the northern hemisphere, which is changing as they come in. They're changing the constellations as it winds all the way in like that, and at the end of the day, you know, it winds back out, and it's pulling away, separating the overlay stars, doing away with the constellations like that. 2 by 2, 2 by 2 into the arc, which is the Physica Piscis. It's basically your alignment, your hemisphere. That's your personal hemisphere, into the arc alignment with the north, your arc. Okay, so there's your ecliptic. There's the ecliptic plane. As it winds around the Earth, you can say it's creating a track like this, like the tropics there, because moving around like this. That's the plane. It's creating a plane around that way, and this is the ecliptic. It's eclipting like the sun and moon. Okay, it's not eclipting. It's completely separated. Well, this is actually completely separated for nearly 6 months of the year. For the sun to be out around the southern hemisphere. Okay, and then once it joins, the field then pops into the north. Okay. You sort of see this in Ken Wheeler's ferrocell, and the magnetic field there. So how it merges and pops in. Because you got to think of this dome and the way the light moves around it, and it just pops into the other side, into the center of his ferrocell and magnet system. Sort of here, and you can see it popping north. Need to look at the history of that ecliptic plane. When did the term ecliptic plane come into play? Yes, I just looked up the term ecliptic plane, and it's a modern term. Okay, it's a modern term. So, although we've got eclipting here, back in the ancient times, I don't think that they didn't use that term, you know, because it's only eclipting for so long, isn't it? 6 months of the year. Then it's not eclipting. Okay. So I just thought I'd show you that why they're calling it ecliptic. plane. So they must know, because you know it's ecliptic, isn't it? Otherwise, why are they calling it an ecliptic plane? Ecliptic. There's no plane on a globe. And what's the sun eclipting? What's the sun eclipting? Nothing on their globe system, is it? It's going around with the Earth spinning every day. There's no eclipsing going on. But for 6 months of the year, this is ecliptic. And this overlay is where the sun is moving from Cancer all the way to Big Bang Capricorn. But that's what the field is doing, right up to there, which takes the sun right up to the Arctic centre north, and then pops apart, and now the sun is full time around the perimeter, or you know, popped into the southern hemispheres.